Okay, in this podcast we're going to talk about protons, neutrons, and electrons. As you follow along, you should have a periodic table out. You can take your yellow one out. If you don't have that at home, you can print one from the internet, or you can just have one up as we go. Alright, so let's just talk about protons, neutrons, and electrons and some of their properties. So the symbol that I will use to talk about protons is just P for protons, N for neutrons, and E for electrons. Okay, so let's talk about where they're located. We know from the work that Rutherford did that the nucleus has a positive charge, so we know the proton is located in the nucleus. The neutron is also located in the nucleus, and the electron surrounds the nucleus, right? The proton has a plus charge, the neutron has a neutral charge, and the electron has a negative charge. Now, if we look at the actual mass of each of these particles, sorry about that circle, you would say that they look in the same ballpark. But if you compare them, the relative mass, and you said, let's make the proton equal to 1, the neutron has almost exactly the same mass. So proton and neutrons have the same mass, but the electron's mass would be very, very tiny in comparison. Okay? So almost 2,000 times less massive than the proton and neutron. Okay, so the atomic number is one of the numbers that you see on the periodic table. It will show up in different locations, but it's going to be the smaller of the two numbers that you see. And this identifies, the atomic number identifies the number of protons in an atom. And the number of protons identifies an element. We can have elements where the number of neutrons changes or the number of electrons change, but for an element, the number of protons never changes. So it's the key identifier of the element. So if we look at the periodic table, let's identify what the atomic number is, or the number of protons for each of the following. If we look at carbon, it's got a 6. Sometimes the 6 is up there, sometimes it's somewhere else, but the 6 means the atomic number equals 6, which means the protons equal 6. Neon, if we look up neon, neon has atomic number of 10, so it's got 10 protons. If we look up krypton, Kr, it's got a atomic number, and therefore number of protons is 36. Alright, so which element has an atomic number of 30? I look in the periodic table. They're all in order of atomic number, and I identify that as zinc. So zinc has 30 protons. Alright, the mass number is not on the periodic table. It is not this number. That is not the mass number. Okay, so I want to make sure we get that clear first of all. But it is the number of protons plus the number of neutrons. If you remember from the previous slide, the mass of the electron is insignificant compared to the mass of the proton and the neutrons. So all we're counting here is the number of protons and neutrons. So let's just show you what that means. So if I have neon, and it has an atomic number of 10, and let's say it's got 10 protons plus 10 neutrons, and if it's neutral, it will also have 10 electrons. And let's just say I identify the protons as each of those has a mass of 1. That's going to be a mass of 10 for those 10. It's going to be a mass of 10 for these 10. And if I, from the previous slide, know that the electron in comparison to the proton and neutron is 0.00055, right? If I multiply that times 10, what I get is 0.0055. And so if I add the mass of all three of those, I end up with 20.0055. So what we're saying is the electron mass is insignificant compared to the mass coming from the protons and neutrons. So the mass of the atom is only considered to be the mass of the protons plus the neutrons. And we arbitrarily assign them a value of 1. We haven't talked about units yet. Okay, so let's take a look at an example. Here we have An atom of sodium has 11 protons and 10 neutrons. So what is the mass number? Okay, so what I know is protons are 11. And if neutrons are 10, what I know is the mass number equals protons plus neutrons. So my mass number is going to be 21. Okay, an element has a mass number of 58 and an atomic number of 26. So the mass number is 58, the atomic number is 26, which means my number of protons is going to be 26. So neutrons will be the combined protons plus neutrons, which is mass number, minus protons, or 58 minus 26, which gives me 32 neutrons. And the question of what element is it? Well, the protons are what identifies the element. If it's got an atomic number of 26, it's got 26 protons, and therefore it is going to be, look it up in the periodic table, it's going to be iron, Fe. Alright, let's take a look at another example. An element has a mass number of 204. How many neutrons? It contains 120 neutrons. How many protons does it have? So the mass number is 204, and the neutrons is 120. The difference between those is going to be my number of protons, which will be 84. And the question of what element it is, I look for an element on the periodic table that has an atomic number of 84, and that would be polonium. Okay, so let's take a look at the charge of an atom. The charge of an atom is determined by the number of electrons that an atom has. The number of protons can't change, but electrons can. So the charge is going to be my number of protons minus my number of electrons. Okay, so let's take a look at why that's true. So if I have, let's say I have the element fluorine, and it has 9 protons, and let's say it has 10 electrons. So the protons are each a charge of 1, so that's 9 positive, 10 negative. If I add those up, I get a 1 negative. Okay, which is why we write the symbol for that as F minus 1. Sometimes you'll see that as F1 minus. Okay, and obviously if the number of protons and neutrons are equal, then an atom's going to be neutral, because if I have 9 electrons, so 9 minus and 9 protons, it's going to add up to 0. Okay, if an atom has a charge, we call that an ion. The term we use is ion. It's an atom with a charge. And then we have an ion when the number of electrons and protons are not equal. If there's more protons than electrons, it's going to have a positive charge, and it will be called a cation. If we have less protons than electrons, it's going to have a negative charge, and it's going to be called an anion. You need to know those terms. Alright, so let's take a look. If we have a lithium atom, the question is, what is its charge going to be? Okay, so I've got to look up lithium on the periodic table, and when I do, I see it's got an atomic number of 3, which means it has 3 protons, which is 3 positives, right? And if it's got 2 electrons, it's 2 negatives, so my charge is going to be 3 minus 2, or a plus 1. So I'm going to write that is lithium plus 1, or lithium 1 plus. If we look at these two examples, what we see is how many electrons are in a nitrogen atom. And a nitrogen atom, we're going to assume that if it doesn't tell us anything about protons and electrons being different, or give us a charge, we're going to assume that it's got a charge of 0. So if I look it up on the periodic table, I see that it has an atomic number of 7, which means it has 7 protons, and therefore 7 electrons. Okay, a sulfur atom has a charge of a minus 2. So I look up sulfur on the periodic table, and what I see is it's got an atomic number, or number of protons, of 16. And if the total charge is minus 2, it must have a charge, electrons, of 18. So it adds up to -2, so it's got 18 electrons. And that's going to do it.